Alright, in this problem we're going to be looking at the work energy theorem, dealing with kinetic energy. We're given a problem with a skier that's going down a slope. Okay, we know the angle of the slope, we know the initial velocity, we know the mass of the skier, and we know that the frictional force is 71 newtons. Okay, if you want to read through the problem by yourself, go ahead and pause this and do that, and then we'll go ahead and work through it. Okay. We know that there is a force that's being applied to the skier, and that's why she's accelerating down the slope. What is that force? Well, if you want to know a little bit closer, let's go ahead and we'll draw the force diagram on our skier. Okay, so here's my skier on the slope. We've got the force of gravity, which is pulling down on her, right? We've got the normal force, which is perpendicular to the surface. Now that normal force is due to the ground, right? And then we've got the force of friction, which is going up in this direction. Okay, she wants to slide down, therefore friction has to be going in the opposite direction. We know that friction is 71 newtons, right? And then if we look at the other forces there, we can get the force of gravity, because we know that the mass is 58 kilograms, so the force of gravity is equal to the mass times the gravitational constant, so that would be 58 times 9.81, and so that's going to give us 568, about 569 newtons. So 569 newtons. And then we know that since we're on a slope here, we do need to tilt our axis, and so we're going to go ahead and tilt the axis here. And so our x-axis is going to be along here, and then our y-axis is going to be straight up and down. And so now we can find the components of the velocity, of the gravitation here. And so by using sine and cosine, we can get the x component and the y component of gravity. And so let's go ahead and do that. We will use sine to get the opposite side, which will be the x component of gravity, and we'll use cosine to get the adjacent side. So we'll go 569 sine, that'll give us the opposite side of 25, because that's the angle that it was tilted, so that's going to be 240 newtons. So 240 newtons is the x component there. And then we've got the y component, which is going to be 569 cosine of 25. Okay, so about 516. So 516 is the y component. And so then we can see that the x component of gravity is greater than the x component of friction, and that's why she's sliding down the slope. Now, since we have a force, and since there is displacement down the slope, that is why we know that there has been some work. And since the question is asking about a velocity, well, work is related to velocity through the work energy theorem, which is with kinetic energy. And so we will go ahead and apply that, and we will work through the problem. And so the work energy theorem is that the work is equal to the final energy minus the initial energy. And so since we know that the work is the force times the displacement, and the kinetic energy is 1/2 mv squared, that would be the final velocity, and then this one would be the initial velocity. And so now we should be able to go through and put in many of these numbers. Now it's important to recognize that this right here is the net force that is in the direction of the displacement. Since the displacement is in this direction down the hill, that means we need the net force in that direction. So gravity is going in 240 newtons in that direction, and then you've got friction, which is 71 newtons in the other direction. And so we're going to take those numbers. We're going to go 270, and 240, and we're going to subtract off 71. And then we get 169. So that is the net force. So we got 169 times the displacement. Now in our original problem it told us that we wanted to know the speed after 57 meters. So we got 57 meters is equal to 1/2 the mass, which was 58, times the final velocity, that's what we're looking for, right? Minus 1/2 times the mass times the initial velocity, which was 3.6 squared. Now all these are in SI already. We got meters per second, kilograms, newtons, and so I don't need to do any conversions. And so now we can go ahead and work this out. When we do 169 times 57, so that'll give us this one right here, so 9633, and then 1/2 times 58, so that's 29. Now many of you will probably be able to do this a little bit faster on your own. I'm just doing it little by little so that there aren't any doubts and no questions about how we got each of these numbers. Okay, so 3.6 squared, and so there we go, 375.84. And so now we can add the 375 to both sides. We're going to go 9633 plus 375.84. And then we're going to divide that by the 29, which leaves us with 345.13 is equal to the final velocity squared, square root both sides, and we get that our answer is then 18.57 meters per second is equal to the final velocity. And that's our answer.